Hello class, this is the video for section 5.4 and talks about logarithmic functions. Now, 5.3 we did exponential functions and we said that exponential functions are one-to-one and therefore they have an inverse. Okay, so here is the inverse function of what exponential. And these are the learning objectives. And we will define what a logarithmic function is, and then we'll change from exponential to logarithmic and then vice versa. And then we evaluate log functions or expressions, determine the domain of logarithmic functions or simply log functions. We will graph and then solve equations involving log functions, okay, or logarithmic functions. All right, so here is a definition. A log function, okay, with a base a, okay, where a is greater than 0 and is not equal to what? 1, is denoted by y is equal to the log x to the base what? The base a. And it's read as the y is a logarithmic with base a of x. Or simply we can say log x to the base what? The base a. Log x to the base a. Okay. And this is defined, okay, if and only if your x is equal to the a raised to what? Raised to y. And this x equal to a raised to y is what? Exponential form of what? Of this function. So this function exists if and only if this is there, because the exponential function is the what? The one-to-one function, and so this inverse must exist. So if this exponential function doesn't exist, then we don't have the log function at all. Okay, what is the domain? The domain of this log function is what? Is defined when the x is positive. So remember, everything you have here, so if you write y is equal to log of something, okay, to the base a, whatever is here, let's put a star, the star must be what? Greater than 0. So that means that if you have log of what? 1, okay, this is 0. Okay, log of 1, it's whatever base is actually equal to 0 or undefined. Let me make sure. So that's log 1. Yeah, log 1 is 0. All right, log 1 is 0. If we have, let's say, log 1 to the base a is equal to, the answer is 0. Why? Because, okay, a raised to 0 is equal to what? 1. Because no matter the a is, anything raised to 0 is what? Is 1. Okay. Now, again, we want to emphasize that the logarithm, the log functions, okay, and exponential functions are what? Are inverses. Okay. The logarithmic functions and exponential functions are inverses. Okay, so all right, so here's a other definition: common logarithmic function. All right, so if you write y equal to log x to the base 10, we can drop the 10 and then just write it as well, log x. Now this type of to the base 10, a log with the base 10 is what we call the common what? Logarithm. Okay, and this is true if and only if what? The x is equal to 10 raised to what? Raised to y. Okay, so you can see that from this, we have what? X is equal to the 10, that's the base, raised to what? Raised to y. So that the question is, what must you raise the 10, okay, to get what? To get x, and that is what? That is y. Now, this is so the function y is equal to 10 to the x is exponential function, and we know that the graph of that passes to the point 0, 1, and then negative 1, 1 over 10, and it's the horizontal axis is the what? Is a horizontal asymptote. Then if we reflect this, okay, the exponential function about the line y is equal to x, then we get the log function y is equal to log s. Okay, now if you look at this log, this function, the red one, you will see we can talk about its domain, we can talk about the range, and so on and so forth. All right, so what will be the domain of this one, in case, just for curiosity? All right, what's the domain of the, we're talking about this function, y is equal to log what? Log s. What's the domain? Domain is anything greater than what? 0. All right, 0 to what? Or just say that what your x is what? Greater than 0, basically. And what's the range? What's the range? Range is what? Range is from negative infinity to what? Positive infinity. Now notice that for the exponential function, y is equal to 10 to the x, what's the domain? Domain is what? For all real numbers. And then the range is also from what? 0 to what? To positive infinity. Now notice that, okay, the domain of the exponential function is equal to the range of the inverse function. Okay, so this is actually the inverse of what? The inverse function of the inverse of the exponential function. Okay, so notice that the range is equal to the domain of the exponential function, and the what? The range of the exponential function is equal to what? The domain of the inverse function. So this is the inverse of that. Okay, and this is the exponential. Okay, we'll list the properties, more other properties in a minute. Okay, so that's a common function. And then we can also define a logarithm with the base what? The base e. Okay, so that's in the next slide. So y is equal to the log x to the base e. Now we can drop the e and write it as what? Natural log. This is the natural log. Okay, this is a natural log. Natural log. That's what we have, the natural log function. So that's the log with the base what? E, which you write it as what? Ln, that is a natural log of x. And this is true if and only if x is equal to what? The e raised to y, because the base is e. Okay, so again, if you reflect the y, the exponential function, about the line y is equal to x, you get the logarithm, the natural log function. And this function, as you can see, it passes through the point. If you reflect this, you switch the what? The x and y coordinates. It becomes this point. This point becomes what? 1, 0. This point here, 1e, becomes what? E1. And this point, negative 1, 1 over e, becomes what? 1 over e, negative 1, like that. Okay, so that's a reflection right there. So now let's find some specific values of what? He said that finding the exact value of what? A logarithmic what? Expression. Now, they find the a, you have for log 81 to the base 3, and then log 1000 to the base what? Base 10. So let's look at the a part. So to find log 81 base 3, you think of it this way. 3 raised to what power equals what? 81. 3 raised to what power equals 81. So you can say that 3 raised to what power equals what? 81. Okay. What must we raise what? 3 to get what? 81. Okay. And that is, so they have 3. What would that be? That would be what? That would be 4. Because you got 3 squared times 3 squared, which is 9 times 9. And that is what? 81. So in other words, the log of what? 81 base 3 is equal to 4. Okay. Or we can say that if you cannot get that straight, can see the multiplicity of 3 to get the answer to be 4. We can solve it in an equation. Okay, we can let's say y is equal to the log. 81, okay? And then we solve it, this equation. So write it as an exponential function, okay? You want to write this as exponential function, which is equal to what? Be 3 raised to y is equal to what? 81. And then let them have the same what? The same base. So the 81 is the same as 3 raised to what? 4. Okay, and then this is 3 raised to what? Y. The bases are the same, therefore your y is equal to what? Is equal to 4. So here, writing as a change to what? Change to exponential. Okay, and these terms, you what? You write the bases, have the same base, and then of course you have y is equal to what? That. Okay, so therefore, again, the log 81 base 3 is equal to what? 4. Because 3 raised to the 4 is equal to what? 81. Okay, so that's the answer. The second part, log 1000 to the base what? Base 10. All right, so you can, this log 1000 to the base 10 is the same as dropping the 10. So I could have written this as what? 1000. The same, it means the same. When you don't see any base there, it means assuming the base is what? The base is 10. Okay, so the question is, what must we raise the 10 to get what? 1000? And that be what? That'll be 3. All right, so it means that the log, okay, 1000 is equal to what? Is equal to 3. Okay, or we can say that we can solve like we did in the previous example. Y is equal to the log, okay, 1000. Then we write it as and solve this equation. You have what? 10 raised to y is equal to 1000. And then the right hand side, we can write it as to the third, and then 10 to what? To the y. So since the bases are the same, it means that y is equal to what? 3. Therefore, the answer is that the log base 10, the log 1000 base 10 is equal to what? Is equal to 3 as your answer. Okay. So now let's go the other way. You are given what? You are given the log function. You want to write it as an exponential what? Function. Okay. So we have log 8 base b is equal to 3. In other words, what must I raise the b to get 8? Okay. What must I raise the b to get 8? So that is b what? This is b, sorry, that's b to the third is equal to what? 81. Okay, is equal to 81. All right, so we are right. This is written, this is the exponential form. That's the exponential form of what? Of the answer, exponential form. Okay, then part B2, we have for log c to the base e is equal to -2. So this is true if and only if exponential form will be what? E raised to what? -2 is equal to what? Is equal to c. Okay, so that will be your what? Your answer. Okay, we are not solving for c. Just say that writing as what? Exponential form. All right. Okay, so here we are changing each exponential form to what? A log function. All right, so what is the base? So we have to be log. Okay, what is the base? Okay, it will be log e. All right, we use that definition that, okay, y is equal to log x base b, written as an exponential form as what? X equal to a raised to y. All right, so if I have the a part, which is what, 16, sorry, I said 16, 1.6 to the third is equal to what? W. Okay, so if you compare this, all right, your x is 1.6, and then your a, okay, your a is the base. Sorry, your x is the what? Is the W. Okay, x is the W. Your a is the base, which is what? 1.6. So this is going to be log W base what? 1.6 is equal to what? 3. All right, that is for that answer. Okay, that is for the answer. B, so what we have, see what you have here, x is equal to a raised to what? Y. Like I said, your a is what? The 1.6. Your y is the what? It is the 3. And then your x is the what? Is the W in this case. Okay, then we have what? E raised to u is equal to what? 25. Now, whenever you see E, okay, in this case, that's the base is E. So it has a natural log. So this is written as what? A natural log, not, or you can just say log to the base E, all right, equal to 25 is equal to U. Okay, which is the same as saying that is natural log of what? 25 to what? To U. The same thing. Either you have this or that. Okay. All right. Now, like we stated from the graphs that I showed you, the domain, these two, the logarithmic function and the logarithmic function and the exponential function are inverses. So the domain of an exponential function is a range of the log function. And then the range of the exponential function is the domain of the log function. So here are the two statements that the domain of a logarithmic function equals what? The range of the exponential, which is what? From which is greater than 0. Okay, that is the domain of log function. And then the range of the log function is what? The domain of the exponential, which is what? All real numbers. Okay, so we have this property, same thing. The domain is what? Between is greater than 0, and the range of for the log function is what? All real numbers. Now, it says that let's find the domain. Let's find the domain of this logarithmic function. Find the domain of this logarithmic function. Now, from the definition, okay, when you have a log of x to the any base, you have the function is equal to this. This is when x is what? Greater than what? 0. So whatever you have here, we know that log of negative number is undefined. Okay, if you use your calculator to evaluate, say log -2, it will say it gives an error. Okay, so to find the domain of this, is just what? Excuse me. You just pick this one and set it to what? Set up the inequality and then solve. So you have to do the what? The inequality. The inequality is x plus what? Plus 2 greater than what? 0. See what I have there. Okay, x plus 2 is greater than 0. So that means that, or this is what? X is what? Greater than what? -2. Okay, so the domain of the f of x is what? Is either you write it as a set notation, x is what? Greater than what? 0. So -2. Or you can say that from what? -2 to what? To positive what? Infinity. This is the interval notation. Interval notation. Okay, so that's the domain for that function. So basically take what is here and then set up the inequality and solve that inequality. But solving this inequality is just basically move the +2 to the right hand side, and that gives me that. Okay, or if I use the number line, okay, if you set up this is equal to, or you can just say that x plus 2. So I have to set up this inequality. Okay, first you have what? X plus 2 is equal to 0 and s is equal to -2. So you have -2. Okay, and then you test on this function, on this one, which one is positive. Okay, so test value here, let's say -3, and let's use 0 on this side. So if you plug in 0 into this, okay, so 0 plus 2 is positive. Okay, this side is positive, and the -3 plus 2 is what? Negative. So you have that. So only this part will satisfy the what? Inequality. Okay, so we did it solving inequalities in chapter 3. All right, and chapter 4. Okay, similarly, we are given this log. Remember, this is log to the base 10. Okay, so we take up the what? That rational expression to find the domain. Okay, oh, sorry, to find the domain. Okay, you have 5 plus x divided by 5 minus what? X greater than 1, greater than 0. Okay, so you have to find the what? The zeros of the numerator. Okay, the zeros of the numerator in this case is what? Is -5. And the zeros of the denominator is what? Positive 4, positive 5. Okay, so then we have this number line. Okay, we have -5 and then positive 5. Okay, so then we test this our function. In this case, our f of x is what? 5 plus x over what? 5 minus x. So I just pick some test values there. Okay, for this one, let's use a -6. Over here, let's use 0. And over there, let's use what? Positive 6. So if I plug in, okay, -6 into that. So that is -6 plus, sorry, that should be, okay. It is, it should be 5 minus 6 over 5 minus 6. So what does this give me? That should be a negative in the numerator, and then the denominator will be plus. So this is what? Negative. Okay, now use 0. The numerator is positive. 0 plus what? Plus x is positive. The denominator is what? 5 minus 0 is also what? Positive. So this is positive. Okay, and then also, if you pick 6, the numerator 6 plus 5 is positive. And then 5 minus 6 is what? Is negative. All right, so this side is what? Is negative. All right, so the only place, the only interval, all right, that satisfies this what? Inequality is what? Between -5 and then what? And then 5. Okay, so therefore your domain, the domain of what? The g of x is the interval from what? -5 to what? To 5. Okay, that's what satisfies the what? The inequality. Okay. All right. So that's the domain. Now, properties of what? The log function. we were talking about, I was explaining earlier on with the graphs. One is the inverse of the other, reflected in the line y is equal to x, the domain, and then the range. So the other properties that we're going to list. Now from these two graphs, f of x as your function, the log function or logarithmic function, okay, is equal to log of x to the base a, where the base is always positive, the base can never be negative. Okay, the base is positive, is greater than what? Is greater than 0, and it cannot be what? It cannot be 1. Now, if you remember exponential function, which we define as what? A raised to what? X. Same thing, a is greater than 0, and a cannot be equal to 1. And so we had what? Two cases where your your x or your a is less than 1 and greater than what? 0, or your a is greater than 1. So similarly, that's what we have here. Now for exponential functions like this, a raised to that, if your the base is between 0 and 1, it's a decreasing function. So that is why in this case the blue y is equal to a to the x is what? Is a decreasing function like that. And then for exponential function, a greater than 1 is an increasing function. That's why in the b, your a is greater than 1, the blue is what? Is increasing. Okay, so to get the log function, which will be in this case log x to the base a, you just have to reflect the graph of the exponential function in the line what? Y is equal to x. So interchange the x and y coordinates. That gives me the red what? The graph, which is the log function. Okay, so similarly, if you have a is greater than 1, you have an increasing exponential function. And then when you what? When you reflect it in the line y is equal to x, you have what? Also another, this is increasing, this is increasing, this is decreasing, and that is also decreasing. Okay, so when a is greater than what? 1, the log function is what? Is increasing. Okay, log x base a increasing. And then over here, it is what? Decreasing. So that this function is what? Is decreasing. Okay. All right. So now let's put all these properties together. First, the domain is a set of positive real numbers, or from 0 to what? Using interval notation. The range is all real numbers. Okay. All real numbers. And then 2, the x-intercept of the graph is what? Is 1. And there is no y-intercept. Okay, compare this to the exponential function. Exponential function doesn't have x-intercept. It has only one y-intercept. So you see the opposite of that. The y-intercept or the x-axis, sorry, in this case, the y-axis is a vertical asymptote. Okay. The log function is decreasing, as we said, when your base is between what? 0 and 1. And then it's what increases when the base is what? Greater than 1. Okay, so, and then the graph of f contains the points 1, 0, a 1, and then 1.5 for 1 over a negative 1. Okay, and then finally, the graph is smooth and continuous with no corners or gaps. And then we can see the slides, the graphs in the what? In the previous slide that we talked about. Okay, which is right here. All right. So here, if I want to give an example of that, say you have a log of, say, 1/2 of x. The base is 1/2. Here, you get log of x base 2, for example. All right. So we have this. We just finished talking about. Now, let's take an example. We want to graph a series of them. We will find the domain. We'll graph it. determine the range and then the vertical asymptotes of the function, and then find the inverse function as well. So in this example 5, we want to find the domain of the log function, which is f of x is equal to 2 times the log of what, x minus 2. We want to graph it. We want to, from that graph, we want to determine the range and then the vertical asymptote. So finding the inverse function, find the domain and the range of the inverse function, and then we also graph what, the inverse function. All right. So first, this is the function. What's the domain? Like we said, take the what, x plus x minus 2 and set it to what? Set up the inequality which is greater than 0. And so you take what, x minus 2 greater than 0. And this gives me x is what, is greater than what? Greater than 2. So x greater than 2 is what, is a domain of the function. And then as an interval notation, you have for 2 parentheses to what? To positive infinity. Okay, that is the first part, part A. Now part B, we want to obtain the graph. Now we will use transformations that we learned before. Okay, we'll start with the basic function, or the, which is y is equal to log of x. Okay, what's the base of this log? Is 10. The base of the original is 10, but we don't write it. Okay, then we use transformations. Now, before even we go, if I have y is equal to 2 log x minus 1. Now this part, okay, if you are replacing x with x minus 2, you're going to shift this word to the right, horizontal shift 2 units. And this 2 is what? Is a vertical stretch by a factor of 2. You understand? So we're going to go through that process. All right, we have the other graphs here. First, we want to graph the function what y is equal to what? That it goes through the points. Remember, is 1, 0, a 1, and then what? 1 over a comma minus 1. Okay, so my base is 10. So in this case, I have, it's going to pass through the points 1, 0, all of them, 10, 1, and then what? 1 over 10, negative 1. So that's why I have these points, 1, 2, 3, and then you graph them. Okay, the line x equal to 0 is your what? The vertical asymptote. All right, so then we, instead of x, we're going to replace this what? X minus what? X minus 2. Now, what is that graph? This is what is a horizontal shift. Okay, it's a horizontal shift. Okay, horizontal shift to the right, 2 units. Okay, so that's why we have this graph. So that means that the vertical asymptote will move 1, 2 units. So the line x equal to 2 becomes your vertical asymptote. All right, you are adding 2 to the x coordinate of each of the points. So 1 plus 2 gives me what? 3, 0. 10 plus 2 gives me 12, 1. That's why I have this point. And then 1 over 10 plus 2 gives me 21 over what? Over 10. So that's why we have those points. And then we go to the test stage. Okay, we have this graph, then we multiply it by 2, which is what? Which is a vertical stretch by a factor 2. So in that case, what do? We multiply each of the y coordinates by what? By 2. So negative 1 by 2 gives me what? Negative 2. 0 times 2 is 0. And then 2 times 2 times 1 is what? Is 2. Okay, so if it's a vertical stretch, you multiply the what? The coordinate by what? By that factor, the y coordinate of each point by 2. So that gives us that graph. So that's part A, part B. Okay, now part C is a find the range. All right. Now, as you can see from this graph, okay, as you can see from the graph, what is the range? That's the y value. What's the range? This would be what? All real numbers. Okay, it's all real numbers. And the vertical asymptote is what? The line x equal to what? Is equal to 2. So from the graph, okay, f of x is equal to that is what? The set of all real numbers is what? It's the range. The range is all real numbers, and then the vertical asymptote is what? The line x is equal to 2. Okay. Now we want to find the inverse function. Go to the 3 steps. Let y equal to f of x, and then interchange. So we have what? Y is equal to f of x, which is 2 log in parentheses x minus 2, and then interchange the x and y. That gives me x is equal to 2 log. Okay. So then we are solving for what? That's a step 2. We solve for y. So we have this function equation. I think I have there. Okay. It is what? X is equal to 2 log y minus 2. Then we divide both by 2. So we have x over 2 is equal to log, okay, log y minus what? Y minus 2. All right, the base is what? The base is 10. Okay, the base is 10. So we're going to write this as what? Writing as an exponential form. That gives us the base 10 raised to what? X over 2 is equal to y minus 2. And then we add 2 to both sides. Okay, so you have what? Y, or you have what? 10 to the what? X over 2 plus 2 is equal to what? Y. Okay, so the steps 1, let y equal to that x, f of x, and interchange, and then solve for y. So now your y is what? Is equal to the inverse function in terms of what? In terms of x. So therefore, the inverse function is what? 10 raised to x divided by 2 plus what? Plus 2. Okay, so we find the inverse. All right, what will be the domain? Domain is will be the range of that. So anyway, we talked about the domain of f inverse is a range of f, okay, which is the set of what? All real numbers. Is a range of f, which is the set of all real numbers. So we got that from part C. Okay, and then the range of the inverse function is the domain of f. And from part A, we found the domain to be from what? From 2 to what? Positive infinity. Okay, so the range and then the domain of what the inverse function are respectively 2 to positive infinity, and then what? All real numbers. Now now we want to graph. Okay, since we're going to graph, we graph the function f, and then we reflect it in the line what? Y is equal to what? Y is equal to x. That's what we do. So to get the graph of the inverse, reflect the graph of f about the line y is equal to x. Or you can use transformations to do this, but it's easier using graph this and then reflect it that way. All right, so here is the graph. Okay, this is a graph of what? The y function, the logarithmic function. Okay, we just had this graph. So we're going to reflect it in the line what? Y is equal to x. Now, how do we get it? This point, they will switch coordinates, so it becomes -2, 22 over what? That's why we have this point right here. Okay, and then this point, which is what? 30, becomes what? 0, 3. That is this point. And then that point, which is 12, 2, becomes 2, 12. So 2, 12. Then what happens? The vertical asymptotes will switch, becomes what? A horizontal asymptote for the exponential what? The inverse function, which is the exponential. Okay. Now, since these are inverses, notice that if we compose f of what? F inverse of x, if you simplify this, you should get x. Also, f inverse, you compose the f inverse with what? The function f. Okay. It should give you what? You should get x as well. All right, so now let's solve some equations involving logarithms and exponentials. So how do we solve the equation? First one, log 3x minus 4 to the base 5 is equal to what? Equal to 3. So the first step is that we want to write as an exponential function and then use the tricks or the skills that we learn in solving what? Exponential functions in section 5.3. All right, so first let's write this and change this to what? Exponential form, okay, which becomes 3x minus 4 is equal to the 5 raised to what? Raised to 3. Now 5 raised to 3 is what? 125. And get 3 what? 3x minus what? Minus 4. Okay, so you have what? 3x is equal to 120 what? 129. Okay, we add 4 to both sides. So divide both sides by 3. Okay, you have x is equal to what? I believe it's 43. Okay, 129 divided by 3 is what? 43. Now, caution, anytime you solve any equation, you check the answer, particularly with equations involving logarithms, okay? Because some of the answers could be extraneous, and you don't want that to happen. So we have x is equal to 43, then we check our answer, meaning we plug in the 43 for x into the log function and see if we're going to get 3. So that is log base 5, and then 3 times 43 minus 4. Is this equal to what? 3? That's a question. Okay. So what is 3? 3 times 43. That is 129, as we just said. So this is equal to, that will give us log, okay, 129 minus 4 is equal to 3. That gives us this base 5. So we have for log, okay, 125 base 5 is equal to 3. Well, this means for what the left-hand side means that for what, okay, 5, the base must be raised to what equals 125, and that is 3. So you get 3 is equal to what? 3. And that is check. And therefore, your solution set is what? The solution set is the set what? 43, period. Okay. Two more. Now, it says solve this equation. Okay, log 81 base x is equal to 2. Okay, so first you change it to exponential function form. Okay, which means that it's be what? Be 81 is equal to x raised to what? X raised to 2. Okay, so in this case, I have to write the what? 81 such that the base, the exponent is what? Is 2. So then there's a number, okay, raised to 2 is equal to x what? X to 2. And that number is what? That number is what? Is 9. Okay, or that number is plus or minus 9. Okay, so either plus or minus 9. Okay, so it means that x is equal to plus or minus what? Minus 9. But what do? We discard what? The negative now, because the base, all right, the base cannot be a negative value. All right, so we use the square root and solve that. So because the base of the logarithm must be positive, we discard negative 9 and check the potential for what? For the solution 9. Okay, so we check that. What is that? If we check this, what would that be? Well, that is what log, okay, 981 is equal to 2. Okay, what must we raise 9 to get what? 2, and to get 81, and that is 2. So that is what? That is check. So the solution set is what? Only 86 is down here. You can see that the solution set is what? That is 9. That's the solution set. Okay, and then finally, we want to solve the equation e raised to 3x is equal to what? Is equal to 7. Okay. Now, again, we change the exponential. This time it's in exponential form. You want to get it in the what? In the logarithmic form. So since we have e, now this is the base, the e is base, it's a natural log. So what we do is that to change this to logarithmic form, all right, or take natural log on both sides, okay, I can have for natural log of what? E raised to what? 3x is equal to natural log of what? 7. And then we use one of the properties of logarithms. If you have natural log of that, you can write this as what? 3x natural log of e is equal to natural log of 7. But natural log of e is equal to 1 because any log to the same base, okay, the base is equal to what? Is equal to 1. And so therefore you have 3x is equal to natural log of 7, and divide both sides by 3, you get natural log of what? 7 over what? Over 3. So this means that take the natural log of 7, divide the result by what? 3. This is called, that is your exact what? Exact solution. This is the exact solution. To approximate it, that is your calculator, natural log of 7, then the result divided by 3, and that will approximately 0.649. So this is called the approximate what? Approximate solution. Okay, so either you take natural log, or you can just, you have what? E raised to what? 3x is equal to what? 7. So we write it in a logarithmic form, which will be what? Log base e of e to the what? Log base what? Base e of 7 is equal to what? 3x. Okay, and that is the same as what? Natural log of 7 is equal to what? 3x. And then when you divide both sides by 3, you get x is equal to natural log of 7 over what? Over 3. So either you change it to the log function, or you take natural log on both sides, and that should give you same results. All right, so with that, that is the end of what? This video, and I'll see you in class. Thank you. So you check the solution set, and that's the solution, and then you get, you always write it the exact, unless the question says what do you call it, approximate it to a certain what? Decimal place. Otherwise, that's the answer. Okay, I will see you guys soon. Bye bye.